Hey folks, welcome to the second series of videos in my YouTube channel CJS IT Studio. In this series of videos, I'll cover on mastering cloud computing. Basically, cloud computing is a kind of distributed computing where we use multiple computers to perform some processing. And why we are using distributed computing or multiple computers? Because there are some enabler applications, and I'm calling them as enabler application because they are quite large or huge applications, large and huge in terms of either they produce very large amount of data or they are computational intensive. So I'm calling them as a large applications, and two such example are maybe large scale scientific applications or commercial applications. Large Hadron Collider is a scientific application that is situated in CERN, Geneva. And when it was started, it was expected that LHC may produce 200 petabytes of data in an year. And frankly speaking, if I arrange this 200 petabyte data in stack of DVDs, then this stack might go up to 21 kilometers. And similarly, the Facebook's data is around 300 petabyte. And besides Facebook, there are similar applications like search engine and other social networking site, which is producing huge volume of data. So LSD is both producing huge data as well as computing on that data. And for such a gigantic applications, initially we were using supercomputers, but they are quite large and quite costly. So scientists have started founding the simpler solution to this, and they'll ended up with these type of computings. We'll see one of each of them one by one. So beginning with cluster computing and how the cloud computing is evolved with these computing, I'll be covering in today's lecture. And this is a simple example from a food chain. In normal life, the food chain we used to say is like big fish eats the smaller fishes. Similarly, the food chain of computer is also there. But here, big fish is like mainframe, then mini computer, then workstations, then PC. But here, it seems a bit different because in distributed computing, the food chain is just reversed. These small fish together with forming a group of computer and eating all those bigger fishes. As in this illustration, you can see that small PCs are grouped together to form a very big fish. And this is the reality that in these distributed computings, we are arranging a group of personal computer to perform same task, but this is quite fast than mainframe and other supercomputers. First term in this computing series is the cluster computing, and this is the cost effective and failure safety alternative to supercomputer. Cost effective because they are quite cheaper, and fail safe because they are multiple. If some of them fails, other may continue their part. So the computing will not stop, but the supercomputer is a single computer. If it fails, your computing will be failed. So in cluster computing, as homogeneous computers, by homogeneous I mean similar platform, similar hardware, they are working together to perform the same activity, and the control will be centralized. So there will be a central control on these all homogeneous computers in a cluster environment. Then after cluster computing, when it was unable to fulfill the requirement of different application, another computing environment is evolved, that is peer-to-peer computing, where multiple computing elements contribute of their resources to perform some processing, and the resources can be computing power like processor, then storage or network bandwidth. But here they are all the peer are independent, they are just coordinating with each other, and this is a decentralized environment in contrast to the cluster computing. Initially P2P environment was used to share the large files like multiple DVDs or multiple CDs together, they are shared in the form of peer-to-peer computing. Sometimes it happens that the computational requirement are beyond the capability of single computer or P2P environment, like the processing requirement of a Large Hadron Collider we saw in the first slide. Then in such case, we try to perform the computational power of multiple clusters so that they can perform the desired functionality and they can provide us desired processing power. And for LHC, grid computing was evolved, where they have shared capability of geographically distributed clusters. By geographically distributed clusters, I mean that they are distributed in multiple countries, multiple time zones, and they are forming a single logical virtual organization. So grid computing is sort of cluster of clusters. So multiple clusters distributed geographically are united to form a single virtual organization. And in grid, it was suggested that these clusters should not be homogeneous, so multiple organizations having heterogeneous clusters may part in it. And generally the idea was to have a mutual collaboration, like in LHC, the data is shared among all the participation clusters, or sometimes it may be on revenue basis or donation basis. Like there are some donation basis grids created for the awareness on the cancer and this environment, and there might be some revenue based. So these are the three basic reasons of collaboration among the multiple cluster to form a grid computing. And once grid computing is evolved, then for revenue generation, another term is coined that is called as a market oriented computing, where consumers are paying to use the resources provided by the providers, and where each of the user is providing some of the computational or storage capacity to their users. So whenever you are using their facilities, you might be paying something to them in according. And real life of concept of economy is used as a basis of market oriented computing. And the capabilities of cluster and grids can be used as an infrastructure in market oriented computing, where you are paying for the computational or storage resource used by you. The next term in this series is service oriented computing. In service oriented computing, the focus is to provide various kind of business processes in the form of web services, and these are web-based programs which are designed for the software agents. Like another web program, we can envision web service, for example, a weather service. Everyone cannot establish a weather service station because that is a costly affair, but nowadays we can see weather details or weather forecasting on every website. So these weather service providers have created a web service where any website can call their web service and display weather information there. So this service oriented computing is also evolving along with these distributed computing. And these concepts of grid, market oriented and service oriented computing are combined together to form cloud computing. So cloud computing is again multiple clusters distributed geographically. This is focused on economy, and facilities are provided as a services. And here are few terms that are new with the cloud computing are the dynamical scalable. Whenever you need to add few more computers for your computation, that scaling can be done automatically. And these are the computers are virtualized. Actually they are not the real computer, instead they are virtualized computer, and we are providing this as a services. So the concept of grid, market oriented computing, that is the grid computing focusing with economy and providing services in the form of service oriented computing is we can call as a cloud computing. Here the services can be software as a service, where you are providing some software on web like Java compiler, C compiler, or some real application like an ERP application or some resource management application, shop management application, any kind of application can be there. Second type of service is known as platform as a service, and where we are giving some software platform like a software development platform like a in Java development environment or Python development environment. Next type of the popular service in the cloud computing is infrastructure as a service, where we are providing some hardware like network or hardware in the form of service, like purchasing or renting a server in the cloud is part of infrastructure as a service. Initially there were three services like software platform and infrastructure, but these days it's like everything is being provided as a service. So with the evolution of cloud computing, now we will be seeing everything as a service, and it is expected that on one day cloud computing will be like these utility service like water service, gas, electricity, transportation, television, telephone. So computing will be one day the nth utility, where like this utility service you can use computing also as a routine thing. So using this concept, generally computing is being transformed in a model where we can use these things as a services. These are the facilities by the cloud computing. It is a one single integrated environment where a collection of resources and services are available. A user need not to worry about the management. They can assume it as a zero management because that is done through the service provider. And infinite, I'm saying it as an endless possibility because it supports elasticity. You can, just like elastic, you can stretch your number of server because of the dynamic scalability. The servers and resources will be available infinitely because there are multiple resources. If some of them down, still other may keep functioning. Performance will be higher, manageability will be less, and that's why we are calling them as a one single environment, 1-0 infinite in cloud computing. And this was a new concept, but it was envisioned long back, like in 1960. John McCarthy has suggested that computational may someday be organized as a public utility. Like these days, they are available in the form of we can hire a server anytime through Amazon or other service providers. And even Douglas Parkhill in 1966, he wrote in his book that about the computing. So the book title was The Challenges of the Computing Utility, and those concepts he envisioned is quite similar to cloud computing. And the definition of cloud computing by Weiche is suggests that cloud computing is again internet-based computing where these resources which is shared. By shared resources, I mean they are shared among multiple users, but each user has its own limit. So the shared resources, software, information are provided to the users on demand, just like we demand for electricity. In the similar way we get them. And in the cloud computing, the resources are dynamically scalable because they are virtualized resources and provided as a services. So these are the important term here. Another definition is by Professor Rajkumar Bhuiya is cloud computing is a type of parallel and distributed system where multiple computers work on the single task. These computers are virtualized computers and dynamically provisioned at runtime, and these are under the contract that we call as a service level agreement. This is all for today's video. In the next video, we'll continue from here. Feel free to like, subscribe, share, Thanks.